Hi everyone, my name is Anvita Bansal and we are back with another lecture based on matrix. It's been a long time that we have done a live stream. So okay, been on a break for a week. Let's start with our today's lecture. Let me show you the question. Okay, you guys can see my screen. Okay. So the question for today is number of palindromic paths in a matrix. So in your SDE sheet, if you'll check, you will find this question here in the matrix section. If you go print all palindromic paths, so if you click on solve option, this is the question that you're going to get. Okay, so what you need to do is you are given a matrix containing lower alphabetical characters only of size n into m. We need to count the number of palindromic paths in the given matrix, and path is defined as a sequence of cells that you can study. We are allowed to move to right and down from the current cell, that is the direction we can choose. And in this matrix you need to find out how many palindromic strings you can get. Okay, and the direction that you can choose to go from current cell is either right or it is in the down direction. So let us see how you can solve this problem. Let me take this example. So for this example you can see the answer is 3. So let's understand this problem, how to do this. So this is a, I would say this is a very good problem based on recursion, and if you optimize it then DP. Okay, let me fine. Let's take this array. Okay, so how do you find palindromic paths? First thing is, what is a palindrome? A palindrome is nothing but a word or a string in which if you read from right to left or you read from left to right, the string should come out to be same, exactly similar. What does this mean is that first of all you need to know what is a palindrome, and you need to check that how many palindromic strings can you find in this matrix. So you visualize this as a matrix of this form. Wait, let me draw a matrix here. So for example, this is your matrix. Okay, you are given a matrix of characters which contains small alphabetical characters, small alphabetical characters. And let me just draw this one so that I can show you how are we traversing over them. Okay, cool. So this is A, B, B, A, A, B, B, A. Fine. So this is your zeroth index. This is 1, this is 2, this is 3, 1, 2. Fine. So what you are doing is that you are at certain position. Let's say you are starting from 0, 0th index. Okay, you are starting from 0, 0, and you have to reach to the last cell of this matrix, which will come out to be n. Let's say n is the length of this matrix, and n is the number of rows, and m is the number of columns. So n minus 1 comma m minus 1 is the index at which you want to reach. You start from 0, 0 and reach till this. Basically you start from here and you reach somehow here. Now what is the pattern in which you can move such that you get a palindromic string, and you need to return how many such palindromic strings you get. So as I was discussing, what is a palindrome? If you see a string like this ABC, if you read it from left to right, that is ABC, or if you read from right to left, that is ABA, that is also ABA. So ABA is a palindrome. If I take a name like this, let's say ABBA, BBA, is this a palindrome? So let's have a look at this A. Okay, this is these both characters are same, these are same, these are same, and this is the middle character, which is a palindrome in itself. So basically I hope you have understood that palindrome is any word or a string in which the characters, if you divide it into two halves, the first half is exactly equal, similar to the second half, right? Or in a string it is equal. Or you can say that if you read it from left to right or you read from right to left, the string comes out to be the same string. Okay, that's your palindrome. Fine. So how do you move in this matrix such that you start from 0 comma 0, you reach till this index and you get a palindrome? So if I do my traversal in this way, that I can either go in right direction or I can go in down direction. That is what your question has told you. So if I'm at this position, I have how many options? Two options. Either I can go in this direction or I can move in this direction, right? Now for every cell I have this similar option. If I am at this position, I can either move in this direction or I can go in this direction. Now which going in which direction gives me the answer. So this whole thing is all about understanding how you are exploring the paths, and it is leading to you to the making recursive calls finally. Okay, so when you come at this index, every cell has two options, right? Okay, when you at this index, you again can go here or here, but the point is which movement will give you a palindrome. So let's come back here. Let's start from this position. I come here, I get a. Okay, I get a. Then I go, this is 0 comma 0. Then I go to 0 comma 1. I get an A again, 0 comma 1. I can go again right or left. I am taking right direction again, A. This is at what? 0 comma 2. Fine. Then I do one thing, I go down in down direction. Then I get A again, and that is at 1 comma 2. You just keep the track of these characters. Then I go to the right direction, that is at 1 comma 3, and I go to the finally last cell, that is your 2 comma 3. So do you see the string that I'm getting here is a palindrome? All the characters are same. So what is this path? So this path is following in this direction. Now the thing is, how will you calculate number of paths which is giving you a palindrome when you start from this index and reach at this index? So another thing that you need to take care here is that the catch in this question is that you need to also keep a track whether the string at which, whether that cell where you are is a palindrome or not. In order to understand palindrome, we need to be at two ends of that string. For example, I was currently at this position and now I'm at this index. So assume that A from here, there must be some characters, let's assume. So what is my first step to check whether it's a palindrome? I will check the two extremes, extreme left and extreme right of that string. If these both are equal, okay, then I can check for the remaining part, and I'll keep on doing the same thing for the remaining ones also. So at every step, I need to check if these characters are equal. For let's say I am at this position right now. This is my window. Okay, I started from here. I am at this position. So what I am doing is I am checking. I am assuming that this is all that I have. So are these characters same? Yes, these characters are same. So at least so far I have got a palindrome. Okay. Then either I can move in this direction or in this direction. So I choose to go in this direction. Now what? Now again, since I am at this direction, I check, is this character equal to the starting character? Yes, it is. It is. So I can say, okay, at least the extremes are equal. Let's move ahead. Now when I go at this position, it says that, oh, I'm not equal. So definitely a palindrome will not be found if I continue in this direction. So I further go in this direction. It checks for itself. Then I can go at this direction and I can check. Now the catch here is that, see, whenever you are traversing in this matrix, when you have to check the palindrome starting from 0 comma 0 and ending at this n minus 1 m minus 1. So whenever you are at this position, you again have two options. What are those two options? Either you have reached at this position from the top, just a cell above it, or you have reached at this position from a cell just to the left of it, right? Because that's how the movements are taking place. Either from a cell you can go in the down direction or you can go in the right direction. So if you're at the last cell, you have two options. Either you have come here from the top cell or from the cell just to the left of it. So what you need to do is you need to check all the possibilities that, okay, I start from here, I go in these two directions, and let's assume I have already reached here. So what are the possibilities of reaching here? There will be two options. So all in all, what I am trying to deliver here is that the variables that are changing here are not two variables, there are four. The state here would be 4. Why you have four changing variables here? How? See, you start from certain index, from there you have two options. Let's say you start from I comma j, right? From here you have two options. Either you go to a next row that is in the downwards direction, or you go in the right direction, that makes you go at j plus 1. And now, because see why we have four variables here, the reason being that we have to also keep a check for palindrome. And in order to keep a check for palindrome, I also need to know what is the last value of the string that I am traversing over. That is the last character of my string. So the last character would be, let's say, PQ. Basically it should be finally at this cell, that is n minus 1 comma m minus 1 index. Okay, n is the number of rows, let's say. So again, when I'm comparing P and Q, again have two options. Either I have reached this cell from a cell above it, that is P minus 1, one row above it, or from a cell 1 to the left of it, that is Q minus 1. And that's how I'm making the comparison. So at every cell for I comma j, I have two options. For every cell at P comma Q, again I have two options, right? So in this way, now what all options you have? Let's say now another thing is, this is the motion that you are performing, or the number of variables that are changing, from which you are going to calculate the number of palindromes. Now comes the other factor that comes is that how are you going to keep the track of the strings that you are calculating? That okay, this is the string at this call and I have some string. How will you track the answer? For example, I start from 0 comma 0. At that point in time, I have a string. Let's say I start with a null string. Okay, string. Then I come at this position 0 comma 0. So it adds to itself a. But now what? Assuming that I start my p comma q from n minus 1 comma m minus 1. So the last index is AA, right? Now I have to check if A is equal to A, then all the remaining characters between this string, all the remaining characters of this string, can I get a string or a substring between A and A which is also a palindrome? So entire traversal or entire call recursion would be checking for this thing, okay, and so on and so forth. The thing will be repeating for itself. Now the thing is, when I'm starting P comma Q from n minus 1 comma m minus 1, I should keep a track of what all strings I have traversed so far. Okay, so what I'm going to do, that I am going to see, either you take a DP array, that will be 4D DP array for this question, or what can I do is I am going to do a recursion. I am going to solve this problem using recursion, in which I am also taking another data structure to store my answer. Here I will be using hash map. Hash map will be of type string, which will tell me what is I, what is j, what is p, and what is q. In short, what is the whatever string I am at, what is the first character of that string and what is the last character of that string, so that I can make a comparison if these extremes are equal. If they are not equal, then there is no point of further exploring the options for going down or top or bottom and so on. Why? Because it will not be a palindrome. So I will stop my check there. That is why for base case condition, this will help me a lot. So key will be string, and your value will be of type integer, which will tell you the number of answers of such palindrome so far. Okay, so what we will do is, let's see here, let's say that now I start from what should be your base case. You are starting I from here, j from here, p from here. Initially your I is 0, your j is 0, your p is m minus 1, your q is n minus 1. Okay, when I start my iteration, let's say there is this function called int path, in which you are checking for paths and you are passing lots of things. You are passing this matrix which is of form array. Then you are passing I, J, P, Q, right? Ij is the index of the first character of that string that you are evaluating, and PQ will be the last character of that string that we will be evaluating. Then M comma N, let's say, will be the, I'm passing the number of rows, number of columns, and then map which will be holding the, okay, what is the string, or what all indices I have for that string that I am evaluating. Okay, let's say this is something like this. Now the base case condition should be in this way, that if whenever you are going down, okay, whenever you are making the recursive calls, you're doing either I plus 1 or j plus 1. So I should not exceed the number of rows, j should not exceed the number of columns. And when you are checking the options for this cell, you are doing p minus 1 and q minus 1. So minus 1 should be in such a way that you do not exceed 0th row and 0th column. Okay, so let's write it here. If I is greater than, m is the number of rows, I is greater than equal to m minus 1 is the last index, which is the valid index, or j is greater than equal to the number of columns, that is n, or your p is less than 0, or your q is less than 0. These are the cases in which my answer will be 0. That means that I'm not going to get a palindromic string for that path at least. Okay, these are some cases. Or if, let's say, I'm traveling in such a way that I have reached my p and q is somewhere at this point, and let's say this is pq, and my I has incremented the index of p, or maybe my j has incremented the index of q. In that case also, that is also not a valid case. That means no palindrome was found. So or your I is greater than p, or your j is greater than q, or you can also write one more thing, ARR of, let's say the matrix is of character type ARR of ij, that means the first character is not equal to the last character. Okay, is not equal to ARR of PQ. So these are the cases when you should return 0, that is, you will not get any answer. Then in which case you will get an answer. You will get an answer only if ARR of ij is equal to ARR of PQ, right? And since we have already handled the cases where it can be out of bounds, so you do not need to take care in this condition. Now you return 1. Fine. Also you keep another check in which, let's say your I is at this position, j is also at this position, and p is at this position, and q is also at this position. So, or at max, I is also here, j is also here, p is also here, q is also here. So what I'm trying to say is, at max the possibility is either you go to till the last cell at which your PQ is present, or PQ goes till the cell at which I and j is present. They should not overlap each other or exceed their indices. So that condition can also be written here. If mod math dot absolute of I is the index of the first character minus p plus math dot abs of j minus q should be greater than or equal to 0. Okay, sorry, less than or equal to 1. Either it can be 0 or it can be 1. It's the absolute value, right? That is the modulus value. So it can either be 0 or 1. It should be greater than or equal to 1 in that case also. Or it can be what? Your I, either I is equal to p and j is also equal to q. That means both are present at the same cell. So in this case what? In this case also you can Basically you need to ensure this, and then accordingly you will return your answer. Fine. You will check, in that case you will return 1, and if this is the case you will return I minus b. Just a second, let me check if you guys. Okay guys, people are here. Fine. So what I was discussing, that see, in this problem, this is actually a, I would say, a very good variation of DP. I'm just writing a pseudocode here, you will understand. Now the thing is, where are you keeping the track of those characters which you are including in your answers, right? You are taking some palindromic value, you are adding them, and now what I'm doing is, let's say I take some int answer as 0. Okay, then I will explore all the recursive calls which can give me answer. So my recursion will go to this function path, and what will be the values? So I'm not writing everything, I'm only writing the changing variables. So you go one row down, okay, j, and when you are at the last character of your string, for that you have two possibilities: either you are coming from top to bottom, or from left to right? So, and you have started from I plus 1 and your j is same. Let's say I am taking this case for pq, in which I have come from the top, that is p minus 1, row minus 1 comma q. Other answer is answer equal to, now answer plus equal to, you are adding these answers, what all possibilities are there, these cases will handle whether to give 0 or 1, and then you go ahead and check if I am okay. Now this path is corresponding to one row down, same column, and let's say I have reached the last cell from the left index. Okay, j will remain same, p will remain same, q will become minus 1. Another recursive call will be to path, and the variables that are changing is, row will be same, I am going to the one column, next column to me, that is j plus 1, and let's say I am reaching the last cell from just one level above me, so that will become p minus 1 comma q. And fourth possibility is that my row is same, my column has changed, and last cell I have come up from the value just before me, that is one column to my left, I j plus 1, p will remain same, and q will be minus 1. So these are the possibilities that you are handling. So before you make these recursive calls, you check what is the current string. Okay, so string str is equal to, let's say this is null, okay, I plus j plus p plus q. These determine the indexes for which you are calculating the first character of your palindrome and the last character of your palindrome. Then you will ask if map contains this. If map dot contains this string dot contains key this str, then what? Then you simply return map dot get str. That is the answer, because basically map dot any set of these characters is telling you how many palindromes were found when your starting character was this and your ending character was this. Okay, so that you will return. Then you will make these calls, and finally in your map you are making these calls only when you were not able to find it in map, right? That is why you will put map dot put that str value, and answer will have all the number of answers that it has got from all the possible path, answer, and finally you return answer. So this is all about this question. And if you see in this question, when it was a normal 2D DP, okay, how we used to do, we used to create a DP array, a 2D DP array where we had two changing variables. Okay, in this case we have four changing variables. So clearly if we also use a loop, or even in this case also, what we have done, we have stored this answer. Okay, we have already put a check using a hash map, we could have taken DP. So basically this is total of on into m in on square into m square of time complexity. The reason being, for every option, for every cell I have two options, down or right. Again for the other cell, bottommost cell, that is this part of your array has two options, again right? So each of them multiplied will be n into m into n into m possibilities, and we are handling this using a hash map in which we are storing the answers and checking if it is already present. We are, so why this is memoized way and not exactly recursive way? Because we have used map here, which is keeping a check. If this has been calculated, don't calculate and move ahead. Use the value directly what is present in map. That is what map.contains is doing. Let me now just show you the code so that you can understand it better. While less than or equal to 1, where, let me show you the code and then answer you. Have a look here. See, this is exactly what I have written in the pseudo code, which you can verify. Okay, see, I'll tell you. If this is the base case that we discussed, the extra thing is that I wrote this test case, I wrote this condition separately. Okay, whenever it is not equal, you return 0. That will not matter. Okay, so what I'm doing is, what are the base case conditions? You start from ij, you and your ending cell is at here I1, I2 and J2. Here I1 and J1 is the starting cell and I2 and J2 is the ending cell. So first case is that the starting cells should not be less than, the starting cells should not exceed the maximum number of rows and maximum number of columns. That is what we have done here, right? And J1, I2 and J2, which is the ending cell of your, which is the last cell of your matrix, when you do -1, you should not go less than 0. That is what we have done here. Then matrix of I1, J1, this ensures if those characters are equal or not. They are not equal, that means there will be no palindrome, and this ensures that your row index of that first character and the last character should not exceed each other, and this is same goes for column. That is what we have handled, right? Then what is this? This ensures that, I'll tell you in the blackboard. So what is that condition which you were asking me in the chat? The condition is that, for example, let me take this array, then I will tell you. See, what is happening is, let's say I start with ij from 0, 0. This is I1, this is J1. Okay, and then this is your I2 and this is your J2. Fine. What is happening is, I am making those recursive calls, so I am ensuring that I've already told in the first base case. Let's come to the second base case, which is math.absolute case. Okay, what it is saying that when you are at this position such that you have only 2 characters in your string and there are no internal characters between those strings, right? Means there is no substring between them. Let's say total string is this only, AA or AB or CD, whatsoever. So whenever you are at this position such that your I is, let's say these possible cases can be, your PQ is here, your IJ is either at this position, I1 J1, or I1 J1 is at this position, or I1 J1 is at this position. In or I1 J1 is exactly at the position where I2 J2 is present. So in all these cases, what you are trying to achieve is that if there is difference of just one row between I1 and I2, right, or there is only one column of difference between J2 and J1, right? J1 represents this column, J2 represents this column. So that means there is no internal substring in that case. And again if I get what, that means that you will get a palindromic string, because we have already handled the case. If let's say these characters were not equal, then it will hit this base case condition and it will return you 0. If we are coming at this condition, that means whatever position we are, definitely the characters are equal. That is why we have come up at this second condition. Now we are checking if they differ by only one row or only by one column, or they are present exactly at the same, that is the total number of characters in your string is just 1, this is representing that both I1, I2, J1, J2 are in same cell. In that case, you return 1. That means you have got one palindromic cell, right? That is the last case. Last case when you have traversed over all the characters. Now you are left with only one character in your string. And then this is your recursive call that I have explained, that you check in map if you have already evaluated for those characters. See, if I am now, let's say I have also not hit this condition, that means neither I am out of bounds nor I have got a palindrome so far. That means I need to evaluate the characters and the palindromes if they are existing. So I'll ask my map, have I already calculated for these characters I1, J1, I2 and J2, right? These two cells. If so, directly return that value. Otherwise, you calculate what will be the answer for that. So for that, I will be exploring from I1 to next row, from J1 to next column, and simultaneously I have two options for the bottommost cell that I am handling with. If you have any doubts, you can ask me. If it is still not clear, you can write in the chat. Otherwise, you can try to solve it on your own. See, these are the conditions that we have written here. If I submit it, fine. So we are done with this problem. If you have no doubts, then I think we can wrap it up. Okay. So that is all for today, everyone. Then see you all on Monday with the next lecture based on matrix. Thank you, everyone. Then bye bye. Take care.